Out of gas? Have zero battery? Just can't do it? Energy. Sometimes you don't notice it until you're out of it. But what is it really, energy? Energy can be a full tank of gas, or a well-rested body after a hearty lunch, or being on top of a hill. Wait a moment, just being in a place, how can that be energy? Well, where else would the speed be coming from when you coast down a hill? The movement down the hill is also a form of energy, enough energy to get you some of the way up onto the next hill. Did you notice what happened there? Energy in the form of being at the top of the hill was converted into energy in the form of movement, and then back again to being at the top of a hill. Okay, energy can be different things. It can be fuel in a tank or food in the stomach. That's 2 examples of chemical energy. And it can be standing on the top of a mountain with a potential to go down, potential energy. And it can be coasting downhill. That's an example of kinetic energy. There are even more forms of energy. Heat, for example. Nuclear energy that we get from nuclear power plants. Light is a form of energy too. Radiant energy. And sound. Sound waves are also a form of energy. Energy has a remarkable property. It can't be destroyed, and energy can't be created. Energy can only be converted from one form to another. When Philip pushed his scooter up the first hill, chemical energy in Philip's muscles was converted into movement, or kinetic energy. Then, when Philip reached the top of the hill, he had converted kinetic energy into potential energy. And when he coasted down the hill, the potential energy was converted back into kinetic energy. Energy converting into new forms in a chain. Maybe you noticed that he didn't get as high up the second hill as where he started from on the first hill. Some of the energy leaked out as friction on the way, which became heat, waste heat. You'll find these kind of energy-converting chains all around you. In a nuclear power plant, nuclear energy is converted into electrical energy and some waste heat. Electrical energy goes through the wires to a bulb, where it is converted to radiant energy and quite a lot of waste heat. Somewhere else, wind is blowing at a turbine. Kinetic energy from the wind is harvested as rotating kinetic energy and some waste heat from friction in the turbine. The rotating movement is converted into electricity in the generator and some waste heat. Electricity charges a battery and turns into chemical energy and some waste heat. The battery feeds electrical energy into a motor and some waste energy. The motor converts the electrical energy to movement and some heat, of course, and so on. Every piece of the puzzle is a process that converts energy. There's an input with some form of energy, then something happens, and there's an output with some form of energy, and some is wasted on the way. If we measure the amount of input energy in a process like this and compare it to the output energy, we get a measure of how effective this particular process is. This procedure is called efficiency. The more energy is spilled in the process, the lower the efficiency. We can measure the efficiency of an individual process or an entire chain of processes, like this. Some of the methods used to generate electricity are very efficient. A water power plant, for example, converts more than 90% of the kinetic energy in the water to electricity. A coal power plant, on the other hand, rarely reaches more than 1/3. The reason for this difference is that heat is a very disorderly form of energy. Particles whiz around and vibrate randomly in all directions. Electrical energy, on the other hand, and water behind a dam wall are more orderly forms of energy. The electrons in the water molecules move in the same direction at the same time, and it's always easier to go from order to disorder rather than disorder to order. 2 important things. Energy can't be destroyed or created, only converted. And it's easier to go from a well-ordered form of energy to a disordered form rather than the other way round.